There's my red light. That means it is time to start talking. Hey everybody, welcome back. Hey, thank you for opening this up and playing this and continuing your educational journey. And as always, I so appreciate being a part of that. Kind of a special day. Got my Nevada High School Tigers golf shirt on. That's in honor of our ladies golf team is at districts today, and hopefully it's going well. And I have it on because I've got one of the members, Katie, who at this point is probably like, okay, why is he saying my name? But anyway, because she's listening to this. But anyway, she sits in my second hour class, and just off to my left, my COVID bubble that I keep for myself. And so, Katie, I hope it went well for you. Hope you're doing great. Katie is a really smart girl, and love having her in the class. But anyway, Katie, I hope you went well, and I hope you advanced on to state. So, with that, hey, thank you. And again, we got a treat. This is Cellular Respiration Part 2. And of course, this is another, the treat is the fact that we're all together. Everybody that I stand in front of and talk about this stuff at whatever school, we're all here together. The A&P courses, both at Crowder and the high school, and the bio classes, both at Crowder and the high school, we're all here together. So that's pretty cool to think about. In my mind, I can picture all the different faces, whether it's second hour, fifth hour, seventh hour, whether it's my Thursday night class, whether it's my Monday and Wednesday night classes, whether it's my fourth hour class. I mean, we're all here together, looking at the same thing, although different time schedules. The first group that will see this will be the bio class at Crowder. Matter of fact, they will see it. This is the 10th. They will see it this weekend, and Monday, Tuesday, Wednesday, whatever they're watching it Thursday. So they'll see it first, and then the bio in the Crowder A&P will see it towards the end of the semester. I think this is either their last or next to last chapter. And of course, the high school students, you'll see it way into probably March. Is when you guys will see this. We end with 8, so that should be in April, and so 7 should be in March. So big time difference, but it is what it is, and that's the way it goes. And but again, welcome, thank you, appreciate you guys, love you guys, and enjoy doing this so much. Enjoy being around you guys. I tell people all the time, man, even especially late in the week, Wednesday, Thursday, Friday, the energy level starts to getting pretty low, but man, I can just feed off of the energy from the students around, and just the excitement and everything. And of course, the Tiger Pride Fridays always help. But anyway, enough about all that ramblings from an old person. Hey, let's get started. Let's get into this. We'll be looking at parts 3, 4, and 5 of the cellular respirations cycle process, whatever word you want to use there. We'll be looking at the Krebs cycle, which is this bad boy right over here. You can see the name right there. Then the ETC, which is this bad boy right here, you can see. And then chemiosmosis, which is always a cool thing for me to talk about from a historical standpoint, my own walk through school. And then, of course, it's such a cool feature. I mean, the scientists that figured all this out, found this, and figured out what was going on. Whoever he is, I mean, hats off to him, because it's such a cool machine. And yeah, I did say machine. You'll see that soon enough when we look at the big blow-up picture of it. But incredible stuff. I mean, I can't say it enough times, and I say it all the time, but what your body does, what your cells do on their own in an efficient manner, without seemingly any real brains. I do that in air quotes, as you saw there, but behind it, just simply the genes off the chromosome giving the instructions, and You know, you can't point to the one thing saying, all right, that's the thing that's driving this whole thing from an intelligence, you know, standpoint. But hey, it's amazing, and like I said, I say it all the time. And if you're ever somewhere with me, we just sit and talk science. I know that that I always mention that. I mean, and that happens a lot more at the Crowder classes because we just have more time to sit and talk and have those kind of conversations. And it may be because it's just a little older set of people who are a little more in tune to conversations like that, and not wrong that the high school didn't do it, but I do enjoy those. And I know Jerry's one of those that I enjoy talking to about that kind of stuff, and the A&P classes, we get into that a little bit. So I enjoy those conversations, and love talking to me some science, love talking to me some bio stuff, and I'm just enamored. I don't know if enamored is not the right word. That kind of sounds more lovey-dovey kind of stuff, but just what would be the right word? I guess just amazed at what it can do, and just in awe of the process that is just simply doing their job, and without seemingly just doing it because they know what to do and they're programmed to do it, and it's just amazing to me. But I better move on because I keep saying the same thing over and over again. That's my clue to move on. All right, so hey, let's get started. As always, got my glass of water here. We're pre-lunch, so it's water right now. But and actually, no, never mind. I was going to go on to what's happening today, but somebody in my Crowder bio class is asking me to talk less about food, which I don't know if that's going to be possible. But anyway, or they didn't say less, but certainly reference the fact that I do talk a lot about it, and I do. I love me some food, love cooking, love making great meals, and enjoy that a bunch. It's kind of become one of our mindsets around here. Like I joke all the time that now that the kids are all gone, we eat better and have more elaborate meals now that there's just the two of us than we ever did. Trying to squeeze in soccer games and volleyball matches and baseball games and football games and school events and functions and everything. So, but anyway, it's great. So if you're out there and you know who you are, no, I shouldn't say all that. But anyway, let's move on. All right, so hey, let's get started. We're going to get started with a nice little review in this bad boy right over here. And man, we did rainbow pen last weekend because was it a hot? No, I don't know. I think I was just in a good mood. Who knows? But let's pick something a little more scholarly. So let's go with how about a nice light blue today? Yeah, I think that's going to be our choice. This bad boy right over here is going to be our beginning. A nice little review over what we've already seen, just to get it back into your mind, and then we'll get. And I'm actually going to move it out of the way because I need this area to type for the Krebs cycle. So here we go. So glycolysis was that first big step, and the key to think about is that we got the 2 ATPs that we use to start, a little investment, and the amazing thing is that's the last time we have to spend currency, use energy in this process. Everything else is just a gain. So if you can imagine a business to where just a little bit of investment up front, and then boom, the rest of it is just profit, profit, profit. That would be an amazing. Most businesses you got to spend to make a little, spend to make a little, spend to make a little. But the more the sales, like, forget that, man. We're just going to spend a little, and then just fill our buckets full of profit. Which is, again, part of the amazing, phenomenal aspect of them. But then again, remembering that at some point in time we split, okay, and then we got the 2 strands, and same thing is happening on both strands, and that'll be important to remember when we look at the Krebs cycle and the end products. We got to think about that each strand is going through the Krebs cycle, just kind of side by side in the mitochondria there. So when we look at the yields, we're gonna if we count then the yields are going to be double. And you might think, whoa, 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 double. Remember, there's 2 strands going. Okay, and when it shows you the yield, it's talking about the whole process. And then, of course, we get the pyruvic acids, and those get converted in pyruvate oxidation, get changed up a little bit, and then we get that final. We add that enzyme, and we get the acetyl-CoA, which is what starts the Krebs cycle. Okay, so that is our little review there. And so let me, let's do the erasing first. Get rid of this bad boy here, and all this stuff here. All of that, I don't think I have to do that because I think it'll go with it, but just to be efficient and save time. Alright, and we'll close this out, and then we will, I'm going to zoom out because that's a strong teacher move. Look at that, zoom it out, move that over there. Oh, you didn't want to go over there. And then zoom back in at 62. That's my number right there, 62. So if anybody ever asks you, hey, what does he usually have his screen set at when he does his videos? 62% is what that number is right there, in case it ever comes up. Which I doubt that it will. Alright, so here we go. Krebs cycle. Let's get the pen back out. And mainly just because I want to do this right here. Oh, I'm on eraser. Never mind. Back to my blue here. I want to do that right there. And then we'll close that back out because we're going to go text box first. So we're just going to, I'm going to do all of the big points. Okay, and then we will go into the diagram and talk about it. And look at my list. Number 1 was review. I got that done, and now we're on number 2, the Krebs cycle information. So let's start this right here. Okay, so let's see, using my strong teacher skill set, the old outlined format hyphen there. Gotta move my pen, it's covering up my information, but this occurs in the inner chamber of the mitochondria. Okay, once we got done with glycolysis, we moved into the mitochondria. As you can see here, glycolysis happens in the cytoplasm, and we moved inside for pyruvate, and now we're all the way into here, in this inner chamber here, this big old bad boy here, the end of the thumb. If you hold your thumb up, you can imagine a mitochondria there, with this being the end and that being like the nail bed or something. But that's where we are, and then you can see where we're going with the electron transport chain, just right below it, south of it. Okay, and outline format there. And we're going to use our good old electron carriers, and we're introducing a new one today. We talked about it in the intro, the background information at the beginning of the first video, but we're going to use those today. Okay, and this is a 9-step. Glycolysis is a 10-step, and but a 9-step process. And okay, we're also going to use specific enzymes. It's got a particular job that needs to be done, a very specialized job. Oh, that didn't sound right at all. There we go. That didn't look right either, but it is right. Okay, specific enzymes, we got particular jobs need to be done, and anytime that happens, we've got to get particular ones. And so we're using specific enzymes, but we will showcase that. And let's see, we are going to make two molecules. Oh, I don't want that capitalized. And of course this 2 is not going to be in the right spot. And so let me pause right here and close that and come back to here, just because I don't like having that 2 like that. It should be CO, and of course the 2 should be like that. So make this like that whenever you put it in your notes. And close that out, come back to this, little edit, definitely. Oh, I didn't put my strong teacher move in there. And then we're going to reduce, and again, you got to think of what we're talking about here. We're talking reduce, so that should automatically tell you they're going to be gaining electrons, lowering that energy value, that electrical value, either from like a neutral to a -1, from a +1 to a neutral. Somewhere in that capacity, we are lowering their electrical value because they are gaining electrons. But we're going to reduce 3 NAD pluses to, oh, not an M, NADHs. Okay, because we're tacking that hydrogen on, meaning we're carving it off of the glucose molecule, or what used to be the glucose molecule, and we're tacking it onto the electron carriers. And you can see that happens here, and that happens here, and that happens here. Okay, and we're also going to do one to an FAD as well, and that of course is our next note. We're going to reduce 1 FAD to FADH. And again, we're carving off a hydrogen from the glucose molecule, so it's being oxidized. Okay, and we can't say that enough. Okay, to help you to get that mental process down. If it loses the electron that hydrogen is carrying, then it's oxidized. If it gains it, it's reduced. Okay, and reducing that electrical value, that energy level. And let's see, in the last one, we are going to produce 1 ATP. Okay, and that happens down here at the bottom, as you can see that. The energy that is generated from the removal, okay, of part of the molecule, that energy is used to add that third phosphate. We got an ADP, which is 2 phosphates, D for di, and we're going to add that third to make it triphosphate, 3 phosphates. And I think that is our main points there. So as always, since I'm remembering, let me close that and let me zoom in real big, and I'll move it from behind my wonderful picture up there. No, not wonderful. I look pretty faded out today. I don't, maybe it's always that way. I just don't notice it as much. I guess I just need to raise that light. Maybe that's my project later on today. You know. But anyway, yeah. But anyway, you guys are probably saying, "Oh, it looks fine as this," because it helps cover up the badness. All right, so there's blown up, and so if you are we're waiting for a bigger version so you can copy it down, we'll dramatically pause here while you pause the video and get that. A little 3, 2, 1, and welcome back. If you did do that, if you didn't, then you stayed with us the entire time. That's fine. So back up here. All right. So now we're going to talk about, let me get the pen here, because now we'll just be doing more drawing. We've done the typing part of it. So let's start with, we're going to start with this box right here, because this right here is, I mean, once we get back around and I follow up with this is an amazing part. So at the end of a Krebs cycle, you've got this 4-carbon molecule, oxycolate, and what happens is that it bonds with the acetyl-CoA that comes in. It's a 2-carbon, 4-carbon, and that's how you get this 6-carbon molecule citrate that is the start of, or the molecule you get early on in the Krebs cycle. Okay, so that box here, and I will I will speak of this again once we get around and back to the end, because this is a pretty amazing process right here. But for now, I'm just going to say that at the end of the Krebs cycle, you've got this oxycoalate 4-carbon molecule, and it bonds with, okay, acetyl-CoA, and so we are building a molecule here, and that process is done by dramatic pause, okay, dehydration synthesis. That's how we put molecules together. So we know that those two join together and through dehydration synthesis. So, but here we are with the 6-carbon molecule citrate. Okay, so what happens next is, and we're right here, okay, an NAD plus electron carrier is sitting there, and an enzyme pairs off, carves off, removes, however you want to say it, okay, one of the H's and adds it to NAD. So the glucose molecule, or what was formerly the glucose molecule, oxidized. It lost the electron that the hydrogen is carrying. Okay, it's oxidized, and the NAD is reduced because it gains the electron that the hydrogen is carrying. So oxidation reduction, redox reaction going on here. Glucose oxidized, NAD reduced. Okay, and again, I can't say that enough to help you to understand that process. Okay, another cool thing that happens is right here, this acetyl-CoA up here, you can see the CO and the A and everything. Part of that, also a carbon dioxide, okay, is removed, and eventually we'll exhume that, breathe that out, get that out of our system, and that will make its way to a plant eventually, and they will take that and separate the C's and O's and begin that glucose molecule building process in photosynthesis. Okay, so we were at 6. Okay, we carved one off, and now we're at 5. Okay, because of the CO2, one of the carbons left right there. All right, and also we lost that H as well. Okay, and then our next process, and now we're right here. Okay, once again, you can see here, a hydrogen is removed, an enzyme, removes that, cuts it off, pairs it off, whatever word you want to use there. So again, the glucose molecule oxidized, NAD reduced, lowering that electron value because we added an electron, which is a negative component. Okay, and another CO2 molecule, okay, is released. So that means we are not only pairing off an H, but we're also pairing off a carbon. And again, energy, anytime one of those things are removed, energy is released, and it's the cell's job to contain that and use that energy. And of course, we're going to use that energy right here. We're going to take that energy that is used to release, okay, and add that third phosphate to an ADP molecule and generate that ATP that we talked about right there. So we lost that carbon dioxide, so now we're down to 4 carbons. Okay, and you can see we keep 4 carbons the rest of the way, so no more carbon dioxide release. We've used the energy to generate that ATP molecule, and so now we're working our way around the cycle until we get to right here. Here's the next big event. Okay, we carve off another H. Okay, again, releasing energy, okay, that the cell tries to contain so it can use for processes. So at this point, again, the glucose molecule oxidized, the FAD molecule reduced. Okay, so that process, again, we can't say it enough to try to help you to grasp that concept. If you're oxidized, you're losing an electron. If you're reduced, you're gaining, and we're lowering the molecule's energy level or electrical level. Okay, but we're still at 4. And again, one more time, we're carving off an H. So you can picture the old Golden Corral roast beef chef, or whatever their name's called, carving off a slice of that roast beef, maybe 2, putting it on somebody's tray. We're doing the same thing here. We are carving off an H, and we are reducing the NAD molecule. We are oxidizing the glucose molecule. So again, keep that process in mind. And then so we have now successfully made these 3. We successfully made that FADH. Oh, I messed up. I didn't put my 2 on there. Hopefully you caught that whenever you wrote your notes, but if not, swing back to your notes and add that, please. And that 2 simply means that you know, I used the metaphor of somebody helping you move with their pickup truck. So you can kind of think of it, maybe the NAD is a Ford Ranger, you know, a little bit smaller pickup. It's still a pickup. You can carry a lot of stuff back there. But then the FAD is more like an F-150 or 250, a much bigger truck that can just carry more, because they can carry 2 of those. Okay, so again, we're thinking of this H removal, okay, as an electron carriers and the oxidation reduction, simply as we're carrying things, we're picking up things from one location and taking them to another. So if you think about, I've used this metaphor many times in person or on these videos, that if you ask somebody to help you move, okay, and so they show up at your house with their truck, and you've got these boxes inside the house. The boxes, for this metaphor, are going to be the H's. So when I carry a box from the house and put it in the back of the truck, the house is being oxidized, the truck is being reduced. Okay, and then when the truck drives the box over to the new house, okay, and somebody picks the box up and carries it into the house, now the truck is being oxidized, and which we'll see in the ETC, and the house, the new house, is being reduced. Okay, and then the truck goes back to the first house, picks up more boxes, so the house is being oxidized, the truck is being reduced, and the truck carries it to the new house, drives it to the new house, and the boxes are taken inside, and then the truck is oxidized, and the new house is reduced. And that's what happens between the Krebs cycle and the ETC. So it isn't just that we are loading up these H's, they're taking them somewhere, okay, to the ETC and getting them ready and then dropping them off for that aspect. So again, that's more of a big picture look at what's going on between the Krebs cycle and the ETC, the electron transport chain. Okay, but now, as I mentioned, back to the cool factor. So we have come all the way around, and now we're back to here. Okay, now the cell does a little conversion and takes this and converts it into, and I always struggle with this, but anyway, oxycoalate is a decent pronunciation. But the key here is that it then binds to the next acetyl-CoA that comes through. So the cell not only does all this work in an amazing fashion, in an efficient fashion, designed to generate energy and to carry the hydrogens away to generate more energy, but then it converts the final molecule into what is needed to start the next process. So it is just a continual process, all this energy release and stuff going on, and then boom, we convert that final product into what's needed for the next cycle. So to me, that is just unbelievable. And then the acetyl-CoA comes in, and then we go through it again. And so we can just constantly do this, all with the purpose of gaining energy to do whatever the cell needs to be done: regeneration, repair, building, enlarging, developing, homeostasis, whatever. Okay, whatever's needed to be done, it can do. So pretty cool, pretty cool, pretty cool. All right, so I did the Krebs cycle diagram, and now we are up to number 4. So let me close this out, and let me slide this up a little bit here, and I will just use this space right over here, because what I want to do now is a little up to this point summary. So up to this point, okay, and then how about a little, I never remember if it's I think this one is the colon, but I never remember if it's semicolon or colon. So if you're an English person, and you can let me know if I did that right or if it should have been the other one. But up to this point, we have made 6. And I'm going to close this and pull this up and just write my little 2 right there, so it looks like it's supposed to, and then close that out, and then come back to this for a little edit. And then we have made 4 ATP, and we have made 10. Oh, I used it wrong. I must have hit the shift button there. We have made 10 NADHs, and we have made 2 and again I'm going to close this out and pull up my pen so I can put my little 2 right there, so it looks like it's supposed to. Alright, and now you're thinking, whoa, 2, we only made 1 over here. Okay, and so I made this point earlier to remember is that there's 2 strands. So what you're looking at is the process for 1 strand. And because there's 2 strands, double everything, so that's where you get that number of 2. Okay, and the same with this, the 6 carbon dioxide, because we made 3 here, but remember there's 2 strands. Okay, we made 2 strands, and the 4 ATP we made 2 here, 1 on this strand, 1 on the other strand, and then we had the net 2 from glycolysis. So that's our 4 ATPs that we have made, which is really anyway, which is where those coming from. So that's what we got to this point. So we've taken that glucose molecule, we've made all this stuff so far. Now, and then these 2 right here, they carried these electron carriers. That's what these are, electron carriers. Carried them to the ETC. Okay, the ETC right there. And that is this bad boy right over here that we're just about to talk about. So, but we just want to do a, up to this point, kind of a summary. And so now, and that was number 4 on my checklist of 9 things to do. So we're approaching the halfway point. And so now I think we are up to, what's 5? The ETC. What I got there doesn't make sense. So, but I think it should be information. Yeah. So let's go. Let's erase this arrow here, and I can squeeze it right in here. And go back to my blue, and then close it out. And get me a little text box. I think I can put that right in here. Okay, so now we're going to do the same thing we did with the Krebs cycle. We're going to type everything out first, so you can get those notes, get them out of the way, and then we will break down the diagram as reinforcement. So we are now ETC and strong teacher move, outline format. Okay, again, we're inner chamber. Mitochondria, and I clicked on an extra button here. Let's make sure that's right. Mitochondria, yep. And we'll do that. Definitely edit. We want to move that over a little bit. Trying to get inside of this. All right, let me look up here. Now, see, that the right there. That's why I paused, because I'm thinking grammatically I needed a the there, but did I want to take time to do it? And I did, and I should have put it up there, inner chamber of the mitochondria. But anyway. Okay, next, outline format and the ECs. And what do EC stand for? Hopefully everybody is screaming electron carriers. Okay, that's electron carriers. So if you want to write out electron carriers, feel free, but that's what the EC stand for. But they drop off the electrons. Okay, they're dropping off those electrons, and you can see that all over here, all these H's. Okay, and we're going to talk about that. Okay, but they're dropping them off. So a little oxidation, if you call it that, but really they're just dropping them off. And next, outline format, and now we're going to use E before I in this word, protein pump, to move, and I'm going to do H, comma, S, N, and you can see that process happening right here. Okay, going all the way back to the plasma membrane and the organelles. These integral proteins, they're going to pump those things in. So all the way back to those conversations we had way back at the beginning of all this. And next, oxygen. Pause there because what I had written next really doesn't need to be said, so I moved on to the next. Okay, in this step you're going to see that oxygen, okay, becomes an electron carrier. Okay, it helps a little bit with the process, and so, but we'll mention that, but you can kind of see that right in this ballpark over here, neighborhood. And there we go. That is the information. So I'm going to take this whole thing and slide it over. Yeah, I got to come back. I got to come back to this, but we will do this part first because that was 6, and number 7 is the diagram that we're going to talk about here and all the cool things that are going on. And you can see this diagram here that we're definitely going to break down the Chemiosmosis ATP synthase machine, but that'll come in time. So now we're talking ETC. There's a pin here. So we're right here. Okay, we're talking. So the first thing to recognize is that the NADHs and the FADHs, they've kind of got distribution spots or drop-off spots. So that NADH, okay, they all arrive here, and the FADHs arrive here, and drop off their hydrogens. Okay, so they're losing their hydrogens. They're coming back to their original forms, FADs, NADs, and those hydrogens move across the membrane down into, okay, the inner space, and we're talking. So now we're looking down here. Okay, we're going through this membrane. This box is kind of in the way, so I'm going to do it over here. Through this membrane right here. Okay, but then they'll go right back, as you can see. They'll go right back inside. Okay, and all this ATP that's generated, that's when that happens. And that's also right here. and right here. So those four, 1, 2, these 3 circles are all the same thing, and that's the grand finale of everything. Okay, so the NADHs drop theirs off, the FADHs drop theirs off, and again we move through, and then you can see by this arrow that we're all moving down, okay, down the line and getting ready for this big final push. Okay, this big final push for everything. And so now we're just going to pause the information button, and let me close this out and move this up and talk about this bad boy right here. I still will go over, and I think about, do I need to do that? We'll see. If I feel like I need to say more, then we'll go over to there. But to this bad boy right here, which may be one of the cooler things that we ever get to talk about, and that's ATP synthase. Okay, that's the official name of this particular pump right here. And man, anytime you got the word rotor and you got stock and you see movement like that, I mean, that is just unbelievable. That not only is it a device used to pump things through, and that whole process of gradients and electrogradients, electrochemical gradients, that processes are all amazing to talk about. But the fact that you've got an actual machine type instrument going on here, I mean, that's just like, I mean, that is way out there. To think about that, we got this going on, but we do. But anyway, it pumps these H's through. Okay, it pumps these H's through, and when it does, okay, that generates energy, so we can tack on a third phosphate to these ADPs. And we're not talking just 1, 2, 3, 4. Our number that we're going to work with, 32. 32. And when we think about that number, okay, and we think about what that means, especially if we go back all the way back to the beginning to my machine metaphor where we're plugging in dollars and getting 5 back. We plug in $1, we get 5 back, and we take one of those dollars and plug that in the machine, and we get 5 more. We take one of those dollars and plug that in the machine, we get 5 more. Using that metaphor, okay, at this point in time, you have spent 3, okay, and got a total of 15, so it means you're netting $12. Who wouldn't do that all day long? Just like your ATM machine type machine, you put $1 in, you get 5 back, you take one of those dollars, put that in, and we would stand there until we just collapsed doing that. But now the metaphor truly is, I take $2 and I stick it in the machine and I get $32 back. Okay, now who wouldn't do that? Because if that takes you, say it takes you a full minute, that's a pretty good hourly wage right there. That's a plus 30. So each minute a plus 30. Oh man. So but that's how awesome the cells are. That's how great the cells are at generating energy. And all you had to do was just eat. Like for example today, and so here goes some food talk. Look out. So if you don't want to hear it, cover your ears. No, just kidding. You know, we're going to Springfield today. Truck needs some oil, and there's nobody around here that does. I could do it in Nevada on a day, but after you've been working all day, and Walmart tells you, yeah, half an hour, hour and a half, you're like, no, let's just make a cool day at Springfield out of it. And anyway, taking the truck in to get the oil change. But what we're going to do is we're going to Hy-Vee, get some pretty good cuts of meat, bring back, put on the grill. Get some side dishes, some of those twice baked potatoes maybe, or just some great baked beans. Who knows? Potato salad, I don't know. But we're going to eat that tonight after we cook it on the grill. A nice little medium rare, more towards rare than medium, but love it like that. But that's all I got to do is eat that steak and just sit back and relax. Probably watch a little bit of the Clemson Miami game, and then at a certain time when that food is digested and those glucose molecules are available for the cells, man, they're going to get to work and generate all that energy, and I'm just sitting back watching the football game, or in that case, maybe sleeping, or maybe it's even the next day, and I'm back at school prep work. But anyway, I don't got to do nothing. I just got to eat and stand back, let the cells do what they do, and they do an amazing amount of work. So let's close this out. Get back up to here, but I really kind of set everything. The H is pumped through and generate this ATP, and H goes through, boom. We tack on a phosphate and generate an ATP, and H goes through, boom. We tack on a phosphate and make an ATP, and H goes through, boom. We tack on a phosphate and make an ATP. Have I mentioned that when an H goes through, we tack on a phosphate and make an ATP? Oh, I did. Okay, good, because that's the main point right there. So we are fast approaching the end, and I'm still thinking about this diagram over here, and if I compare it to what's over here, no, I don't think I need that. So I loaded that one for no reason, so that 30 seconds I'll never get back. But so here we go. These last two are just real big summaries, so let me scoot those over here best as we can. But it's the idea. Oh, we're a little high there. Okay, no, I just have to keep moving around. Well, that's pretty good there because there's nothing below there, so that's pretty good right there. So start with glucose. Okay, going through glycolysis in the cytoplasm. Okay, we moved into pyruvate oxidation, converted to acetyl-CoA into the Krebs cycle. Now we're at that inner chamber, and then when we come to the ETC, we're using this membrane right here. Okay, this membrane, and you can see that inner membrane of the mitochondria right there. And moving those H's through, and then traveling down and back up to this pump, and there's our number right there. Okay, 32, and you can see it also right there. Yeah, that's the collection of the energy, and of course I used the number 32 in the previous little metaphor example as well. And so that is the process, and that's the number that you want to focus on when it comes time to answer questions about that. 32 is going to be our number, and you can see right here, that's why I write, and right there, that's why I write it a lot of times, because I mean sometimes some of these programs there's just not that subset, subscript or exponent option, and so that's why I write it, because it's just not right because those twos like that. But anyway, that's just a little personal thought process there. So now I've included this box, and let me bring this all the way up here. This box here is here because no matter who you are, A&P, Crowder Bio, NHS Bio, NHS ATP, A&P, that I include this square here, this bad boy right here, because when it comes time to reviewing for the test and the multiple choice questions, this is a slide that you really want to focus on, because it has all of the information. It's got the step names, it's got the locations where it happens, and it's got the starting material, and it's got the end products, and every one of those little boxes are great multiple choice questions. So the high school people, you'll have quick access to this because I always provide those PowerPoints or upload the PowerPoints so you can see them. But the Crowder people, okay, I will also make sure I upload that to the Blackboard so you can have that. And if for some reason I'm slow and you want it quicker, just say the word if it don't already have it, and I will quickly do that. But that's the thought process right there. So this slide is certainly one to really focus on. And that's all I got. Man, I hope you enjoyed that. I hope, I know it's a lot of material and a lot of important material, a lot of question-orientated material, and a lot to digest, no pun intended there, and a lot to assimilate and comprehend. But hopefully you enjoy learning about what your cells do. Because I know me personally, and I don't know if I mentioned this or not, but I enjoy talking about this stuff. That was a little sarcasm there for those scoring at home. But anyway, enjoy talking about this stuff, and that's really what this is about: learning what your body truly is doing, your cells truly are doing, as a way to understand what's going on. Because we are not about the things that we like to do and the things that we do for entertainment, enjoyment, whatever, but we truly are what's happening in our cells and going on there. Inside's important, outside's important, but man, to learn what your cells are doing, to me, it is a blast. Enjoy it, love it, and every year I've done this, which has seemingly been a super long time, but I just enjoy it, man. Each semester, each year, look forward to getting to the different ones. And of course, I tell the bio people all the time that 6, 7, and 8, chapter 6, 7, and 8, those are my favorite 3. Love talking about the energy stuff, energy movement, and to me it's just great. But anyway, enjoy. I hope you enjoyed that. And again, as always, man, I hope everybody's well, that things are going well with you, and that you're in a good place mentally, physically, emotionally. Be sure and take care of yourself. Give yourself the grace to have a chance to relax every once in a while, to breathe deep, and just to sit back and kind of just let everything melt away. I know sometimes, especially if you're a crowded person and you're younger, just got out of high school, or you're maybe just a little bit beyond that, in that 25 to 35 range, and you've already got the family. It's tough. You're working, you got the family, you got the school, you're working, and it's tough. Okay, it's tough. I wasn't there for the first time I went through college, but the second time I was there, getting my degrees to doing this. I was there for that, and it was tough, but we survived, and now here we are enjoying it. And you'll get to that point too someday. You'll get to the point to where you're just working and going home to your family, and you'll be proud of yourself for what you did, and you'll be excited for what you're able to do, and you'll be in a good spot then. But just hang in there, get through it, and you've got this. And as always, if any way I can help, just let me know. Just let me know. I say that to the Edge Nudity people all the time. They hear that all the time. But anyway, that's a whole different topic. So hey, with that, we need to get out of here. Say goodbye. And again, thank you. Enjoyed it, and until next time, we will say goodbye.